and welcome back. And today we're back to working on the portable PDP-1123. The PDP-11 portion of it is just this tiny little box over here, and it gave us a ton of grief with the power supply, but well, we were able to get the power supply up and going, and when that happened, the whole thing sprang into life. The CPU and memory card seem to be working perfectly, and we get to the bootstrap menu where we can start telling it what drive we want to boot from. Now, we don't have any drives attached to it, so we're going to have to throw some type of media edit, but we're saving that for the future. And eventually we'll build it all into a custom box so that we have a nice portable little PDP-11 that we can take to events. But a portable PDP-11 is pretty useless unless you also have a portable data terminal to go with it. And for that, I'm going to use this ADDS Envoy here. Now, in the previous episode, we had a we had a rough time. I spent a lot of time hanging around in rodent feces, and I really didn't need to because I got 2 of these from Godfrey down in Houston. Godfrey, thank you so much, you legend. And I thought one was going to be a primary machine and the other one was going to be used as a parts machine. And it just so happened that the one I picked was covered in rodent feces. So I spent all this time cleaning it up. And then I went to look inside the parts machine afterwards, and it was already clean, no rodent feces to speak of. I should have started with this one. But the fact that we cleaned that other one up is good, because I think it might be able to help us out with this one, because this one is not healthy. It is mostly working. It does turn on. The screen gives us a nice white image with a cursor on it. And when we plug it into the PDP-1123 here, we get something, but it's not the right thing, and it's not consistent. So we'll start with some of the simple things. We'll check to make sure that flow control isn't necessary. And I think we also need to check all of the voltage rails. That was one thing that I forgot to check last time because it just seemed like it was going to boot up and start working. And if all of that turns out to be totally fine, then we'll get deeper into troubleshooting. And I think that's where the rodent feces machine is going to come into play. So we have a ton of work. I have absolutely no idea if we will succeed today or not. But there's really only one way to find out, and that's just hop to it. All right, the first thing I always tell somebody that's troubleshooting something that's unknown is to check the voltages first, and then I never do it myself. So that's what we're doing right now. We need a good plus 5 volts, a good plus 12 volts, and a good minus 12 volts. And right now I have 3 probes on pin 14 of a 7402. That should be plus 5 VCC. And then there's an LM709, and I've got it on the plus V and minus V. So we should have plus 12 and minus 12 on those. So let's go ahead and flip the power switch on here. The fan has spun up. We are getting an image on the screen here, so I'll go ahead and hook my probe up to the 5 volts. And that's a little high. That's 6.7 volts. That's like way too high. That could cause problems. Okay, let's try the minus 12 volts. Yeah, minus 12.7. That's totally fine. And here is the plus 12 volts. 12.9, that should be totally fine. It's that 5 volt rail that is a little worrisome. 6.6, 6.8, 6.7 volts seems really unstable and high. That's not right. All right, check this out. I've got the Siglent scope out here, and I've got it set up to 500 millivolts per division, and it's AC coupled. So we're just looking for ripple. We already know that the 5 volt rail is a little high. So if we go ahead and turn the power on the Envoy here, look at that ripple. That is nasty. Well, we definitely have some kind of fault on the power supply, but as you can see, getting to the power supply is an absolute nightmare. Maybe one of these giant filter caps here is no good, but just getting to it in general is going to be a pain. And I think there's a better way that we can get around this, because the feces covered machine that is now clean, I checked the power rails on it and they were working fine. So I think we'll take the boards out of this one, put them in that machine, fire it up, and see if anything changes. I'll start with pulling the VGGT board out from the bottommost slot, followed by the MCGT board from the middle slot. Then I need to get this half-sized board out to get better access to the FEGT board. The power distribution card on the FEGT board pulls out, but all the cabling means I can't get it all the way out. With it pulled up and out of the way though, I can finally get the FEGT board out. Now it's time to do it all again with the poopy parts machine. Getting the outer case off these things is fiddly on a good day, but it eventually slid off. Then I just repeat the same process of removing all the cards and then slipping in all the cards from the clean machine into the poopy machine. I don't have a keyboard hooked up, so I have no idea how this is going to behave. I don't think that should cause a problem, but I only have one keyboard between the two chassis, so I don't want to move it over until I'm sure that this is going to work like it's supposed to. The CRT cage here is a little loose, but everything's plugged in and it should work. Maybe, I don't know, let's turn the power on and see what happens. The fan spun up. I've got all of the boards out of the working system in there, so if the CRT is good, we should see a white image showing up on the CRT here. Well, we got an image. It is nasty and filthy and gross. The image has grown beyond the confines of the screen. I don't know if that's a good thing or a bad thing. I know that adjusting brightness and contrast here, I can either make the image get brighter or disappear. Let's flip the PDP-11 on and see if we get some kind of reaction here on the screen. Nothing, huh? All right, I was really hoping that was going to be our smoking gun, but at the very least, check this out. 4.97 volts, much more stable 5-volt rail, and not overvolting. So at the very least, we've made some progress. I think the next step is going to be pulling that CRT cage out and putting the good CRT cage in, and then maybe swapping some cards around and seeing if we can get the behavior to change any at all. I spent most of yesterday basking in the smell of rodent feces. This thing still stinks. I gotta figure out, if we ever get this thing working, I gotta figure out how to get that smell out of there. It's clean. We did a great job of washing it, but God, does it smell bad. All right, well, anyways, I spent most of yesterday trying to figure out what on earth is going on, and the closest I could ever get it is up to the same point that we were at in the previous episode, where it just prints parentheses on the screen here. I need to figure out more closely what's happening inside, and we don't have any schematics for the ADDS Envoy, but we do have schematics for the ADDS Console 580, which is a larger full-sized data terminal, but it's actually identical to the ADDS Envoy, uses the exact same control boards in it. So there are 4 control PCBs in this machine, but the Console 580 only has 3. The 4th board that is extra is this little guy right here. And this, I believe, is just for the acoustic coupler on the side, which the Console 580 doesn't have, so it doesn't need this board. And we're not using the acoustic coupler right now anyway, so I think we can pretty much ignore this board and eliminate it as a potential source of problems. Of the remaining 3 boards, they are each kind of separated into a unique individual thing. And the 580 manual has this wonderful little block diagram here. You can see the FEGT board has the UART and pretty much handles all input-output. The MCGT board contains all of the memory for the screen display. And then the VGGT board is the video generator board. It's generating that video signal that makes it to the CRT on the front here. And so I have duplicates of all of these boards because I have 2 machines. And so you would think being able to swap boards around, I would eventually hit a combination that functioned, but no, everything is broken on both machines, but they're broken in different ways. So we'll start with the good news. No matter which MCGT board is in the machine, behavior is exactly the same. So we need to shift focus to the other 2 boards. And there is, on the very bottom is where the VGGT board, that's this board right here. And well, you know, we can see on the block diagram that this is the video generator board. But if we look at the schematic for it, this is neither here nor there, but the ROM is really interesting because it uses a combination of a 3-bit address for the row and a 5-bit address for what pixels are being printed. So it creates a nice little dot matrix grid of dots to turn on and off. Really interesting. But the rest of this is all kind of analog wizardry that has to do with running the CRT, and that's all a bit beyond me. So what I really want to know is if the video generator card is working. So I took the one that was in there out, put this one in, and this one is totally dead. This is the one that came from the poop-covered machine. And whenever you turn it on, the screen just stays completely black. So there's some inherent failure on here that's not generating a video signal. So instead, I'm gonna shift focus a bit to the FEGT card. Now that board is this particular board right here, and this has all of the settings to set whether we have parity on or off. And yes, I've gone through and double checked everything, so we do have the correct data coming into this. Now I swapped the cards around. I put the one from the poop machine in, and it was completely dead. Absolutely nothing happens. Didn't even get to the parentheses printing on the screen. So I started tracing them out separately, and on this particular board that was in the clean machine, when I follow the RS-232 signal that's coming in via EIA-in over here on the schematic, it goes through F5, then F3, then B3, then D3, all the way over to serial in on the UART. And I can follow that signal path all the way in, and then I can check on RD1 through RD7 and see that it is sending parallel data out. But on the board that's currently in there, it dies immediately. The serial data comes into F5 and doesn't leave F5. And looking at it, I can see that F5 is a little rusty. So I really wanted to try and eliminate the FEGT as a potential source of failures. But well, if this one has a fault on it, I can't compare it to the other one because the other one never even gets serial data, so we have no idea what's going on there. I don't know, we're kind of in a weird spot. I think that swapping the IC around is gonna be the quickest way to create some kind of comparison point between the two. Before I go desoldering ICs, I gave the PCBs a good once over, and this corrosion here was a little worrisome. So I scratched it away with an X-Acto knife, and sure enough, the corrosion had chewed clean through one of the traces here. After repairing the trace, let's give it another test right quick, and yeah, nope, no change. All right, it doesn't take too long to pull an IC. I might as well get to work. First, I start by adding fresh solder to the IC legs. Then I get my trusty Radio Shack desoldering iron out. I absolutely love this thing. It's fantastic at just sucking the solder right off the IC legs. Then, despite the horrible camera positioning, the IC pops right out without any drama. Unfortunately, I didn't have any 14-pin sockets on hand, but I do have a bunch of 8-pin and 6-pin sockets, and if my math serves me well, that'll work. Once tacked in place, I go through and solder all the legs down. Then I just need to pop the borrowed IC from the other board into place. All right, Poopy board is in with the new driver IC in place, the new old driver IC. Let's flip the power switch on. We should see a white screen here as it warms up. Yeah, we've got a nice white screen going on there. Looks the same as before, only there's no cursor on it. I wonder if I can hit the roll button to get the cursor to show up. Nope. Well, let's flip the PDP-11 on here and see if we can see any difference here. Oh, nope, we're not even getting any parentheses, so that's not great. I don't know, there's 9 million things that can be wrong here. All right, the other poopy FEGT board I think has a bad UART on it because we were getting serial all the way into the UART, but absolutely nothing out of the UART. So I'm back to the original FEGT board, and I started checking it, and I think I may have found a bad IC. So I followed serial data in. We've got it coming all the way in from EIA in here through F5, through F3, through B3, through D3, all the way into the UART. And then the UART changes that serial data to parallel data out. And that parallel data out comes out pins 6, 7, 8, 9, 10, 11, and 12 here. And that looks correct. But where it gets interesting is with C2 and D2 here. These are AND gates that are gating that output out. So let's check C2 pin 3, which is right up here. So that's C2 pin 3 right there. Let's go ahead and flip the PDP on here. And I can see data showing up on that. Okay, so C2 is working correctly. Next, let's check D2 pin 3. So just the next IC over. And that's gonna be this one right here. And already
something doesn't look right. It's not at ground, it's not at 5 volts, it's somewhere in the middle. D2 is not working correctly. So let's check the input into that. That would be pin 1 here. And the input to it is at a logic high. And if we reset here, we can see data going on. Okay, so we have data coming into D2, but we don't have any data leaving D2. So that's definitely gonna cause a problem because it's not gonna send the right parallel data out. So I think we need to replace D2. I'm gonna go ahead and desolder it, put a socket in that one, and see if I've got a new one hanging around. This is the same procedure as before. Add fresh solder, desolder with the Radio Shack desoldering iron, pop a new socket in place, and solder it up. Even though this shot is sped up, it is actually just one continuous take, and looking at the file, it's exactly 5 minutes and 41 seconds. That's how easy it is to replace ICs using this Radio Shack desoldering iron. This thing is pretty awesome. New 74S double aught installed. I've got the terminal back on, nothing went up in smoke, thankfully. Let's flip the PDP on, please be different. Well, I suppose that's a little different. My my cursor went to the center and then nothing changed after that. Ah, there we go, okay. The PDP didn't fully boot up correctly. That's for some reason it was upset about something, but yeah, there we go. Still getting those parentheses. All right, it's been, I don't know, a while. I actually wrapped up filming completely yesterday, and I think I'm gonna throw all that footage away because, well, I might have stumbled across something this morning. So I have absolutely no idea where I left off. So a quick recap. The FEGT card had a bad 74LS00. So with that chip bad, the parallel data was never making it to the backplane. And when it gets to that backplane, it goes to the MC card where it gets stored in memory, comes out of the MC card and goes to the VG card where it goes into the ROM that is the character generator ROM that creates the character to display whatever needs to go on the screen onto the screen. But we replaced that LS00 and it didn't fix our issue. We were still getting just random parentheses out of it. So something else is bad. So I was talking with members of the Discord, kind of dejected and defeated, and Trinary Logic has been a massive help in helping me figure out exactly what's going on in here. And MX Shift suggested tacking on little wires onto the ICs that fly off out the back so I can actually probe them. So right now I've got 1, 2, 3, 4, 5, 6, 7 wires tacked onto different ICs to follow things as they go through the system. And I think I've discovered something interesting at the very least. So we're starting with, over here on the far left, we've got J5 pin 3 and J5 pin 4. This is an input into a hex inverter and the output out of that hex inverter. These S1, S2, and S4, these three create a memory address that chooses which line of the character we're printing of our little dot matrix on there. So those two are checking that. The next two over here are going to be pin 4 of J3 and pin 5 of J3. This is a 74174, and this is the input into it and the corresponding output out of it. Now the next two after that are pin 3 of J4 and pin 4 of J4. This is a hex inverter, so it's taking that output out of J3 and inverting it. That goes into pin 17 of KL4, and we're checking pin 8 coming out of KL4. That goes into a 74165 L6 here, and the last one that we're checking here is pin 7, so our serial data that's coming out of that, generating the video signal that goes off to the video. So I've got the scope on here. Let's give it a test. In order to do that, I'm going to turn the terminal on, and I'm going to get my laptop just vomiting data out the serial port here. So we should have some whatever serial data showing up in here, so we should be able to see something on these. So this is going to be J3 or J5 pin 3, and yeah, we have data coming into that, and yeah, we got data going out of it. Now the levels are different. I don't particularly know if that's going to be a big issue, but that is 5 volts peak to peak, so that, I don't know, yeah, we'll just assume that looks right. Nothing looks really broken there. The next one we're going to check is J3 pin 4. This is the input into that chip. And yeah, it looks like we have some kind of data going on there. That looks all right to me. And then this is J3 pin 5, the corresponding output out of that. And yeah, again, looks like we've got some kind of data going on there. That looks okay. I'm all right with that. That's going to come out and go into J4 pin 3. So this same input is going into pin 3 of J4. That is our hex inverter. We should see an inverted version of that coming out the other side. And we don't. We actually just see 12 volts permanently high. That's not right. That inverter should be inverting something, and it's not inverting. So our whole signal just comes crashing to a halt right there, right as it's going into the ROM. If the ROM is never receiving an address, it's never going to display anything on the way out. So maybe we have a bad hex inverter there. But the fact that it's dumping out 12 volts is kind of interesting. I'm going to need to look up what kind of inverter chip that is, because I don't think it's just a standard LS04. The DM8812, this little guy right here, is a pretty interesting hex inverter. It's got open collectors on it so that it can do some level shifting between ICs. So these are essentially 5-volt ICs, but they're interfacing with the ROM, which is a plus 12, minus 12 volt IC. So the open collector allows them to do that. And that's why we saw that this one, the output was just a solid plus 12 volts. That's because the inverter wasn't able to pull that output down. So I don't have any ones of these in stock. So I went over to the spare video generator board and stole one off of it. And hopefully with that in the socket and the board in there, something changes. Please just do something different. Please, you don't have to work. Just stop giving me parentheses. So we'll turn it on. I've disconnected the fan for the power supply because it stinks. It just blows. Oh, that's different. That's very different. Wow. Okay, I was saying that the fan blows rodent feces smell in my face, but that is bonkers looking. Let's send some serial data and see what it does. Well, it's not just parentheses, but it is different. That's progress. That is actual legitimate progress. That gives us some other direction to run down. Well, I don't know. That was better than where I left off yesterday. That's actually definitive progress. We have it displaying more than just parentheses, although it fills a third of the screen with @ symbols and everything. The cursor's all over the joint. It doesn't make any sense whatsoever. But we did find some definitive faults today. We found that the 5-volt rail on the non-stinky chassis over there is absolutely blitzed. It was sitting way too high and had a massive amount of ripple. But I think we need to fix the 5-volt rail so I can use that chassis, because this chassis still smells like rodent feces. I had to disconnect the fan because it was just blowing that smell in my face and it was giving me a headache and making me sick. It stinks. It smells really bad. It's clean. It just, man, that smell just works its way into the metal. It's just, ugh. Anyways, aside from the 5-volt rail, we found 2 more faults. We had a bad 74LS00 that was blocking parallel data from making it to the backplane. And we had a bad DM8812. This is a hex inverter with pull-ups on it that's also a level shifter. And it was bad, preventing any data from making it to the ROM. We now have data making it to the ROM. Looks to be correct coming out of there. So we still got a problem somewhere else. And I think the cursor might be to blame, and the fact that half of the screen is filled with @ symbols is also a pretty big clue. So in the next episode, we're going to dive deeper into that. We didn't get there today, but we did actually make some progress. This thing is not going to go down without a fight, but progress means that, you know, to quote the Predator, if it bleeds, we can kill it. I don't want to kill it, I want to save it, but it's showing a little chink in its armor, and we're going to get there. So I want to thank you guys so much for watching, and I hope to catch you in the next episode.